This presentation focuses on exploring network automation for IPsec, site-to-site NAT configuration and management. This project aims to overcome challenge in manual IPsec configuration and management in large-scale networks by integrating automation methodologies, advanced algorithm, and best practice. Research examines automate system scalability performance for contemporary network demands. The primary objective of this research proposal is to design, develop, and evaluate an advanced automated system specifically tailored for IPsec with NAT implementation. This system aims to effectively manage IPsec configurations in large-scale network environment. It will be designed to handle complex network topologies, dynamic IPsec configuration, and interoperability with diverse network devices and vendors. By integrating cutting-edge automation methodologies, advanced algorithm, and best practice in IPsec implementation, this research aims to overcome the challenge associated with manual configuration and management of IPsec in large-scale network environment. Next, I will be presenting on the problem statement for this project. So for the first problem, okay, the manually setting up and configuring multiple IPsec tunnels between different sites. So for this one, okay, this can lead to time-consuming and labor-intensive tasks, especially when dealing with a large number of sites. So this process requires manual intervention for each tunnel, including the configuration of cryptographic parameters, authentication methods, and key management. Additionally, it involves configuring routing protocol and access control policies to ensure proper communication between the sites. So the next problem is, as the number of site and IPsec tunnels increases, maintaining consistency and accuracy in the configuration becomes more challenging. Okay, in large-scale deployment, the complexity grows exponentially, making it difficult to keep track of the configuration across all the sites. This can lead to inconsistencies in network topology and security vulnerabilities as misconfiguration or outdated setting may go unnoticed. Next, the manual configuration management of IPsec tunnels presents significant challenge for network operation. So it requires substantial time and effort from administrator, potentially diverting their attention from critical tasks. Moreover, the risk of human error increases as the number of configuration grows, it leading to performance and security issues. Okay. Additionally, troubleshooting becomes more complex in environment with interconnected IPsec tunnels and configuration discrepancies. To address the challenge associated with manual configuration management of IPsec tunnel, the implementation of an advanced IPsec tunnel management system is essential. The system would automate the entire process of setting up, configuring, and maintaining IPsec tunnels in large-scale network. By providing a centralized platform, administrators can establish consistent configuration across all sites. Okay, it can reduce manual effort and minimizing errors. Furthermore, the system would offer efficient monitoring and troubleshooting capabilities for timely issue resolution. So next, I will proceed to objective. Okay, for objective, first, it will automate IPsec tunnel setup and configuration for time saving and error minimizing deployment. Okay, second, improve network efficiency by automating tasks for administrators. Third, examine IPsec protocols, network automation techniques. Fourth, develop advanced IPsec automation system for managing complex network configuration. Fifth, evaluate automation system performance, scalability, and security. Last one, recommendation for real-world deployment and maintenance of IPsec automation. So that's all from me, and I will pass the next presentation to my colleague Muhammad NORFARIS Faisal. Thank you.
Very good day to everyone. My name is Muhammad Nufaris bin Faisal and today I will be presenting IPsec definition and project specification. What is IPsec? IPsec, or Internet Protocol Security, is a complex and comprehensive architecture that enables the secure exchange of security protocols and encryption algorithms. It offers a strong set of protocol algorithms to protect the confidentiality, integrity, and validity of communications. In IPsec consists of Internet Key Exchange, or they call it IKE. It's a key management system that is essential in IPsec VPNs. Its major goal is to make secure communication between IPsec peers easier by establishing security association and negotiating key material for encryption and authentication. The IKE consists of two phases. The first phase is formed when IPsec peers authenticate each other and create a secure channel. During this phase, the peer negotiate security policies and exchange of cryptographic content. The second phase is IPsec specify the parameters used to encrypt and authenticate IP packets. Encryption algorithms, authentication methods, key length, and lifetime are among the parameters. When the IPsec SA are formed, secure communication channel between IPsec peers are established, allowing for secure delivery of IP packets. This is example. Below is a diagram example for IPsec tunnel. Router A to internet cloud and also router B transfer IP packets through internet cloud or the communication between end-to-end devices. As you can see, the the below line, the green line indicates the unencrypted traffic for internet without the IPsec configuration, and the above is the IPsec tunnel. Is the red line which indicates encrypted traffic between end-to-end devices. Next, I will explain the scope of the project. The first is evaluation of existing network automation framework, tools, and methodologies suitable for the IPsec automation. Next, the development of custom IPsec automation system capable of handling complex network topologies and diverse configuration requirements. The third one is integration of automation system with existing network infrastructure and devices. The fourth is performance evaluation and benchmarking of the automation system. Lastly is a comprehensive security analysis and testing of the automation system. Thank you. Next, uh, I will gladly uh, um, ask my friend Fitri to present the method slide. Thank you.
Assalamualaikum. My name is Muhammad Fitri bin Muhammad Saleh. Thank you, my friend and my partner, for presentation. Now I would like to continue our project presentation about the method. So, doing this method, we do the research for the qualitative research method and quantitative methods. So, the research method will be utilized to gain in-depth knowledge and understanding of IPsec protocol, encryption algorithms, key management, network automation frameworks, and related technologies. For quantitative method, utilize the performance benchmarking will be conducted to measure the speed, resource utilization, and overall network performance when implementing the IPsec tunnel with night configuration using the automated system. So, this our proposed project, the network topology. So, we use three routers and three switches, not fully the automatic configuration because we include the manual setup for the configuration for the router, HQ, BO, and ISP. So for the primary objective for this project to establish a highly secure and efficient site-to-site IPsec tunnel with not between router, HQ, and BO, route through the ISP without requiring any involvement of knowledge of the configuration from the ISP. So This project we employed the automation using the Python and include the library NetMiko for the will be utilized to the streamline the configuration process and ensure consistent and efficient deployment of the IPsec kernel with NAT. So the PC at the HQ and BO we using the DHCP configuration. So next we using the two installation. We using the GNS3 for the create the framework topologies, network topologies. So the also we using the GNS3 VMware for the virtual machine, and then VMware Pro for the the software that allow running small operating system on single physical machine. And we also using the Windows 10 for the operating the system that provide a user-friendly interface support the local software tool. So the programming language we include the Python 3 is a powerful programming. So we also use the library at Nemico. So I would like to call my friend to continue the our project presentation. Thank you. That's all.
Okay, hi, Assalamualaikum. My name is Siti binti ROSMADI. I would like to demo our network automation on IPsec tunnel between HQ router to the branch office router. So basically, we control the automation from this network automation device. First, before to start the network automation, we need to ensure that all the router can SSH from the network automation devices. I just run the Python 3 ssconfig.py and run whether the network automation can SSH to all the router. The result is successful for the router ISP, router HQ, and router branch. To test the SSH, I need to enter the router HQ first. One, two, and then I enter the password. So I in router HQ. So to view the IP address, I just enter the interface IPR and so on. So I exit the interface and I test SSH to the HQ branch office router. Since I just entered the password, so I now in branch office router, so I can view all the IP address that I set in the interface. So I just exit. Okay, the connection is closed. So to run the automation for IPsec, I just run the config.py item 3 config.py. It takes several times to do the automations. Okay, so now the result is success. For the HSQ router configuration is success and branch office configuration also success. So to see the file cat config.py, this is the configuration that I put in the config.py. Since all the access lists that can permit to the destination, and I also set the crypto ISA KMP policy, the hash MD5, and the authentication encryptions. So by doing this, I want to ping to the branch office router first to see whether our tunneling is success. So from this result, I can see that our tunnel is success. Now I want to show whether our IPsec panel is accessed by run this config, by run this command crypto isa kmp. So now I can see the source destination IP, and the output show that crypto ISA-KMP simply tells that our IPsec tunnel has been successfully created between the source, this is our source HQ, to the destination. Okay, now I go to the BO router and want to ping at the HQ router. Ping 12.168.2.2. Same, I get the successful, so I just run the crypto SAKMP. Okay, so I get the similar result. So this is the destination, this is the source. So yeah, by doing this, our IPsec tunnel is successful created. Okay, so I want to ping the PC1 no, I want to ping the PC4 from the HQ router first. No, okay, I just want to show the PC1 can ping to the PC4 at the branch office router. So by doing that, I set the IP address the HTTP. So I run the command IPDHP to get the VPC IP address first. So the IP address for PC4 is 192.168.30.2. So I need to ping from the PC1 first. 192.168.30.2. So I ping again. So the result is success. So it means I can ping to from the PC HQ router to the branch office router. Now we do the reverse from the PC4 to PC1. So PC1 IP address is 20.2. So ping 192.168.20.2. So the ping is success. Okay, the ping is success. So from the HQ, I need to ping again. I need to run the to see the number encapsulated and encrypted. So I just run the show crypto IPsec SA. Okay, okay, this is the result. This is the result that show from the HQ router to the branch operator, the packet the number of packet encrypted is 14. Okay, so we can see the local endpoints to the branch office router. This is the local and this is a remote router. Okay, next I want to ping again from the PC1 to PC4 to see whether the packet is increased or not. Okay. Okay, now I just run again the show crypto IPsec. So the result is increasing to 24. So I'm happy with the result because we can see that encryption looks good, and we need to verify. We can verify this result also from with Wireshark. So I just start capture from this line interface. Okay, I just do the I ping to the branch office router, and try to ping again. So from this, from this, I can see the source is IP is to 192.168.2.2, and destination IP is 32, which is the branch office router. So in this result, I can't see the data that are being sent because it's all the data is being encrypted. Okay, being encrypted. Okay, same way if I ping from PC1 to PC4. In this result, I can see the ISMP, ICMP, because the IPsec tunnel is not allowed. The IPsec tunnel is encryption, so the packet, the Wireshark packet cannot capture the packet that been sent from this PC to the PC4. So by doing this, even though that we capture from this side, this traffic from HQ router to branch office router, it shows that the traffic is encrypted by the IPsec tunnel. So basically, a hacker or someone else on the internet is not being able to read or capture the traffic. So basically, our IPsec tunnel is success, and thank you from me. And basically, our topology is an IPsec configuration is success. Thank you. That's all from me.
So, for the conclusions, the successful implementation of network automation for IPsec, including net configurations, hold immense potential for organizations. Is it not only simplifies the management of IPsec tunnels, but also enhance network security, improve overall performance, and free up IT resources for more strategic initiatives. With automations, organization can achieve efficient and secure communications across their networks while minimizing manual errors and maximizing productivity. Thank you.